Right, so we're on lesson 6.6 of Algebra 1. We're looking at graphing systems of linear inequalities. So in the last lesson, we looked at just graphing inequalities. So now we're going to look at graphing systems of linear inequalities. And remember, a system is when you have two or more equations, okay? So our objective, so let's do our warm-up first. So graph the solution. 4x plus 3y is greater than 9. So this is what we did in the last lesson. You want to get the inequality so that it's y is by itself. So we're going to move the 4x over. So we get 3y is greater than negative 4x plus 9. Then we're going to divide everything by 3. So we get y is greater than negative 4/3 x plus 3 goes into 9 3 times. Now, to graph this, we're going to go to the y-intercept of 3, and then our slope is negative 4, 3. So I'm going to go down 4 and to the right 3, put my other point. Now, we need to decide if we want a dashed or a solid line, and if you look, because it is a greater than sign, there's not an equal than also, we're going to use a dashed line. And now we need to decide which side to shade. Well, it says y is greater than, so we would shade what's above, which is up here, but you could also check by plugging in the point 0, 0. So if I put 0 into here, I'll get 0 is greater than 0 plus 3, which is not true, because then we have 0 is greater than 3. So we know it has to be the side that doesn't include the point 0, 0. Okay? All right, so our objective for this lesson is to graph the solution set of a system of linear inequalities when we have two variables. So like I said in the previous section, we graphed linear inequalities to see its solution. And now in this section, we're going to graph multiple equations to find the solution set. So recall that when we graphed a system of linear equations, the solution was the point where the lines intersected. So that's where we looked at the three ways of solving a linear equation, a linear system, was by graphing, substitution, or elimination. And if you graph, it's where they intersected. That was the solution. So in this case, it's going to be where the inequalities overlap. That's going to give us our solution. So we need to graph both inequalities in order to find our solutions. But first, we need to make sure that both equations are in slope-intercept form. Okay? So we're going to look at this first equation. Well, we want to get that into a y equals equation, so I'm going to move the x over. So I'll have negative y is greater than 2 minus x. Then I'm going to divide everything by a negative 1 so that I get y, and because I divided by a negative, I need to flip the sign. I'm going to move this first. If I have a negative x divided by a negative 1, that becomes a positive x. My 2 divided by negative 1 becomes negative 2. For my other equation, I'm going to move the x over, so I get 2y is greater than or equal to negative x plus 1. Divide everything by 2, and I get y is greater than negative 1/2 x plus 1/2. Okay, now we have to graph. Let's graph this one up here first. So I'm going to go to negative 2 for my intercept, and my slope is a positive 1. So I'm going to go up 1 and to the right 1. And now we need to use a dashed line because it is not a greater than or equal to. It's just a greater than. That line didn't turn out very straight. I think you get the point. So there's our first line. Our second line, okay, I'm not gonna shade anything yet. Our second line has an intercept of 1/2. So we're gonna go to 1/2. And then our slope is a rise of 1 and to the left 2, or down 1 and to the right 2, since it's negative. So I'm gonna go down 1, so that would be right here, and to the right 2. So that would put my point over here. And in this case, we are going to use a solid line. Let's see if I can draw that straight. We're going to use a solid line because I forgot to carry it down, but it is greater than or equal to. Now we have to figure out what to shade. Well, for the first equation, the one that was dashed, we would want to shade everything below. Okay, so I'm going to pick a different color. Pick blue. So everything below the dashed line. So that would be everything right in here. For the other equation, let me pick another color. Let's pick gray. For the other equation, it's y is greater than, so it's everything up here. Well, where do they intersect? Let's pick a different color. The part where they intersect is actually only all of this. So technically, we would only shade all of this. If you guys want to, when you're doing this, if you want to kind of like lightly mark where you would shade and then wait till you're done to figure out what parts you should shade together, then that's fine. So like I said, we only want this red part shade right here. Technically, the gray and the blue area, that's not overlapping, so that is not part of the solution. Okay, let's try another one. Y is greater than 1 and x is less than 3. Well, y is greater than 1, you guys, that's going to be, we're going to plot a line at y is equal to 1. So we're going to go up to 1, and it's going to be a dashed line, a dashed horizontal line right at y equals 1. So if y is greater than 1, we know it would technically be everything above. But we've got to figure out now with our second equation what part overlaps. So our second equation is x is less than 3. So we need to go over to x is equal to 3 and also do a dashed line because it's got the less than symbol. It's not equal to. And it says x is less than 3. That would be everything on the left side. So we're going to shade everything over here since it was above the first line and to the left of the second. So that's where they overlap. So again, this is your horizontal line, and this is your vertical line. So we're only shading where they overlap. Okay, why don't you guys go ahead and pause the video and try this one and see if you can get it right, and then watch how I do it just to make sure you're on the right track. Okay, so we need to make sure both equations are in so that y is isolated. Well, if you look, we've already actually got y isolated, so you don't have to actually do anything to solve. So we're just going to graph. For the first equation, y is greater than 1 minus 2x. I am going to rewrite that y is greater than or equal to 2x plus 1, just so I have it in y equals mx plus b form. So my intercept is at positive 1. And my slope is negative 2. So I'm going to go up 2 and to the left 1 and put my dot. Now, it is a solid line, okay, because we have the greater than or equal to. That wasn't a very straight line. I suggest using a ruler just again. Okay, on the second equation, my y-intercept is 2. So y-intercept is 2. And my slope is 1. So I'm going to go up to 2. And my slope is 1. So I would go up 1 over 1 or down 1 to the left 1, whichever way you want to go. Now this is going to be a dashed line. Okay, now we have to figure out what part we should shade. Well, for the first equation, the solid line, it said y is greater than, so that would be technically everything. Let's see if I can do a little highlighter. That would be everything over here, okay? For the other line, let's pick another color. Maybe that, let's see, will blue work? And we'll just go with blue. For the other line, the dashed one, it says that y is less than x plus 2. So that means that y is everything, it's everything below the dashed line. Well, where do they intersect? Well, look at that. It's turning green for us where they intersect. They actually intersect only in this section. So this is the section we would technically shade. The other section are not solutions because they don't overlap. So it's everything in that section where they overlap. Okay, we've got one last example. In this case, we're going to have to come up with the inequalities from the graph. So we have to look at the graph and write the inequalities. Okay, I would start by writing your equations first, getting the general form. Well, this line right here, you guys, do you see how it is a vertical line? Since it is a vertical line right here over at x equals 2, we know that it's going to be x something 2. We don't know if it's greater than or equal to yet. Well, do you see how it's shaded? The part that's shaded is on the left side of the x equals 2. Well, that means that it's got to be everything to the left. So it has to be x is less than 2. So that's our first equation, okay, because it's on the left side. Our second equation, to write it, we're going to find the intercept. Well, look right here. The intercept is right here at y equals -2. So my intercept is y equals -2. My slope is up 1 over 1. So it is up 1 to the left 1. So my slope is -1. So I'm going to write y. I'm not going to fill in which inequality sign yet. Okay. Then our slope is -1, so -1x, and my intercept was -2. Well, what part is colored? It's actually below the line, so that has to be y is less than. And we also need an equal then since it is a solid line. So your system is x is less than 2 and y is less than or equal to -x minus 2. Okay, so again, with today's lesson, this isn't different than yesterday in the sense that you're still graphing the inequalities the same, but this time the only part we shade is where the shading overlaps of the two inequalities. And that is all.